All right, good evening, everyone, and welcome to the BIC. For those of you who don't know, the Berkshire Innovation Center's mission is to accelerate the innovation and growth of existing companies in the Berkshire region. Tonight's topic is particularly appropriate as we look forward to the ribbon cutting of BIC Works at MoCA this Friday. Opening a second location on the campus of a renowned art museum is going to help us highlight innovation within the arts and explore the overlaps between technology used for manufacturing and in other creative pursuits. Tonight we begin with a simple premise. 3D printing will change you. To help convince you of this, we've convened 4 panelists whose work and creative expression have already been changed by 3D printing. Mac Pierce joins us remotely this evening. Mac is an artist and creative technologist who has used not only 3D printing, but a variety of digital tools to create artwork that asks difficult questions about the role of advancing technology in society. John McLeod joins us from right here in Pittsfield. His business has evolved to support artists in achieving their visions, and he's learned to use 3D printing as a valuable tool for that. Stephanie Weber and Eric Drury are here to discuss their work in creating accessible tap dance components for dancers in Kenya. And all 3 have married technology with art in one way or another. Tonight we're going to hear from each of them as they share some of their respective experiences with 3D printing, and then we'll give you all a chance to ask your own questions in the second half of tonight's panel. But before I turn the mic over, I'm going to share some quick background on what 3D printing is, why it matters, and what makes it unique as a creative tool. So in this slide right here, we have an example of subtractive manufacturing, where you start with a block of material and remove everything that isn't your part. This is how most things have been made for a long time. You get a block of stone and a chisel and carve away a sculpture. You get a 2x4 from Home Depot and cut it to length and frame something up with that. And even in our mass manufacturing technology, where we're adding plastic to an injection mold, that mold itself is produced using a subtractive process. So it is limited in quite a few ways. One is that anytime you add design complexity, it gets a lot more expensive. Removing material is a costly process, and the more specifically you want to remove material, it gets exponentially more expensive. You also really need highly skilled operators to run these machines. It's not as easy as just hitting print and getting your part. In contrast with additive manufacturing, which is the industry term for 3D printing, we start with an empty build platform, and you can see that here on the bottom right. And we only add material as needed. So there are quite a few different processes. Generally speaking, we're either melting and re-solidifying a material or exposing a liquid to light and using that to solidify it. What's really interesting about additive manufacturing is we define both the exterior and interior geometry. We can change what's on the inside of a part, and that can be used for things like making a part weigh less, make it stronger in certain regions, embedding things like sensors or motors or fasteners or magnets. But in general, you're able to actually define what's on the inside of a part, which is not strictly exclusive to 3D printing, but much easier to do there. Another thing that it brings is design complexity. 3D printers are robots. They're obedient. You can feed them 1 million lines of G code and they'll execute each one. It's pretty easy to get a printer to make as complex of a shape as you would like. What's also really interesting is despite that complexity, there's nothing preventing that same exact tool from building an entirely different complex part immediately after without changing anything about the printer or the material, just uploading new software, new code for it to run. So 3D printers are sometimes called a toolless tool because in manufacturing you need to invest in tooling up front in order to economically make a large volume of parts. But with a 3D printer, you just need that printer. And then you choose your material, choose your color, and you can print a wide variety of geometries without changing anything about that tool itself. What's really interesting about this is as the technology improves, they get easier and easier to operate. It's closer to just clicking print and getting your part. There's still more to it than that, but if we compare to printers 5 years ago, it's really impressive how much easier they've gotten to operate. And that leads to democratization of not just the production process, but the design process. I think one of the most interesting things about 3D printing in general is how it makes people think differently about design. If you imagine 20 years ago, 30 years ago, 40 years ago, designing something, you'd have to send that out to a fabrication shop and have them build it for you. That could cost $10,000. It could take months. So you put a lot of work into finalizing your design before you have somebody make it. You don't want them to produce a part for you and then get it back and realize that you'd used centimeters instead of inches, or that you have some sort of mistake that you only find months later just because that's the only prototyping tool that you have available. In contrast, 3D printers, we can iterate very quickly. So rapid design iteration is a process that's enabled by additive manufacturing, because you can design something, print it that night, the next morning, see what's right or wrong with it, adapt the design, print again, and iterate over and over and over again. And actually, for Sean O'Neill, Jordan Callahan, and myself here at the BIC, we'll start printing before we've even finished a design. We'll design half of a part and print that half and see whether or not it works. And while that first half is printing, finish the rest of the design. And we'll manage to, produce a part before we've even finished the design, which is a pretty incredible thing when you think about it. So it changes how you approach the design process, because the cost of a failed print is so low. It doesn't take a lot of your time. It's not a lot of wasted material. So I think it encourages people to be a little bit more creative, take more risks in their design. And I think generally speaking, that opens up to the possibility of better designs overall. That's not to say that skill isn't really important here. I think it shifts where that skill is needed, away from fabrication towards the design. And it's not an absolute shift. It's still important to know about fabrication processes. There are things that we can't print, or we can't print well. There are other tools that just do a much better job of a printer. Sometimes in order to make something, we use a laser cutter, we use a table saw, we use a drill press, any number of other tools to augment what the printer can do on its own. So there is absolutely still a skill needed on the fabrication side. But the shift to design, I think, is pretty profound in how we look at producing goods. And when we think about what customized design is, I think one of the best examples is art. Often we're making one-off pieces. Sometimes an installation might have, a higher volume of individual parts, but the design itself is often designed for a single use, single display. And that's what 3D printers really excel at, is this customization, this complexity, and the ability to print just about anything that you can imagine. So just before we jump into the panelists, I just wanted a quick poll of the room. How many of you have seen a 3D printer before? Quick show of hands. Okay, and how many of you have used a 3D printer before? Okay, so about half have seen and about a third have used. That's not bad. We have quite a few rooms without that much engagement. We're now going to turn it over to Mac Pierce, who's going to share a bit about his work. Take it away, Mac.
Hey, thank you, Tim. My name is Mac Pierce. I am an artist and creative technologist that has been working with 3D printing since about 2014. And I've gone through a lot of different iterations of working with it as a tool and as a sort of assistant in the creation of art. And yeah, I'd like to share with you a little bit about my practice and how I've integrated 3D printing into that. So let's see here if I can get the screen share going. Yeah, there we go. And let's do full screen on that. All right, can you see that?
Yeah, we can.
Great. So I started printing back in 2014. And that was right around the time that I was wrapping up my undergraduate studies. And at the time, my university had one of the early MakerBot 3D printers, which is this early iteration, allowed you to 3D print. It was like nothing I'd ever seen before. And at the time, I utilized it to make my own printer, which was called a rep wrap at the time. So printing off parts and laser cutting other parts to build my own printer, which facilitated me down this path of using this tool often now that I was losing access to the university's tools. Ended up building a pretty capable machine that served me well for a few years and sort of taught me the ropes about how to go about thinking about 3D printing. And like Tim was saying, it's a perfect tool for art making. I like to describe what a 3D printer is best for as doing high precision one-offs, which art making is almost entirely about. Um, it also has the fun benefit of being able to replicate the same object multiple times. So if you do need to make multiples of something, you aren't stuck with something like a traditional casting process where you're having to make an entire mold and then wait for whatever it is that you're casting to set up. And then if you do need to make variations on it, do iterations on the mold, which I found to be incredibly helpful. And I can show you a project where that was exactly the use case for it. So some of you may recognize this monument in Somerville, Massachusetts, as the old Powder House Square. I became interested in it because I lived right next to this particular area, and it's one of the oldest stone buildings in the United States. Formerly a powder house used by the colonists prior to the American Revolution. And it was the site of this incident called the March on the Powder House, where the British, just prior to the start of the Revolution, went and took the armaments and the gunpowder out of this particular location, which was a major grievance to the colonists at the time, and helped spur on the Revolution and then the enshrining of the Second Amendment as an amendment into the Constitution. You know, don't take our guns away. This was part of it when they took the guns away. Anyways, one of the pieces that was taken during this march was this large field artillery piece, like a 30-pound cannon. 30 pounds referring to the size of cannonball that it shot. And so thinking about this genesis of firearms and the way that America interacts with them, I wanted to sort of collapse the distance between the current state of it and sort of where we got our start. And so I was able to find some early schematics for these cannon making techniques in this wonderful book, A Treatise of Artillery, which allowed me to translate that into CAD and actually build one of these things fully using 3D printing. Actually using the same printers that are available at the BIC, these Prusa i3s. I was able to go through and do about 13 kilograms of filament to put together a full-sized recreation of one of these cannons. So this is 6 feet long, made up of 52 individual pieces on a welded frame in the same style of carriage that would have been used during the Revolution. And was able to present this piece as part of my, my master's thesis work. I just recently finished up a graduate degree at the School of the Art Institute of Chicago. And so being able to like take this historic object and bring it forward into the modern times was like a really interesting process. But of course, like this is a fully 3D printed sculpture. Not all of the objects that I make, though, entirely consist of 3D printing. And in that way, additive manufacturing has been an incredibly useful tool to just like do small parts, you know, additional pieces on what are overall larger compositions. Oh, before I go too far, this was actually the cannonball and the pedestal for that cannon, and that pedestal is entirely 3D printed as well. It's just the variety of things you can do with these tools is fantastic. Anyways, using 3D printing as a step in larger production, I found to be incredibly helpful as well. For instance, this is a casting that I was able to mock up entirely in CAD and do all the gating and all of the venting and get the exact measurements of how much material I was going to be using in a way where the actual process of undertaking the casting was incredibly straightforward. Using CAD and then additive manufacturing to make this object. For instance, I was able to mock up the exact mold that I was making for this object and then go through and actually 3D print out the positive that I was molding around. So in this case, this is the the very pretty positive that I used, like the end of spools to go and make this object for, and then go and make a sand mold around it for the process of iron casting. This mold here in the middle is actually that piece there, and was able to know exactly what I was going to be getting out on the other side, which ended up being this fully cast iron sort of time capsule, 92 pounds with a hollow in the center. And yeah, without additive, it would have been a much more arduous process. One of the things that I'm constantly drawn back to is, I'm working as a studio artist now. That's my full-time thing. And every moment that I'm in the studio is precious because I need to get a lot done. And having these helpers that are able to just like go through and multiply my time while I'm there is incredibly valuable to me. Like, I have 3 printers now and they're almost all running constantly just to go through and produce objects. In the same vein as what I was saying before, this is another piece that is sort of like a portrait of a computer virus, in this case, the Pegasus virus. And many of the pieces on it were made through additive. For instance, this here on the front is not an actual phone, but it's an LCD screen that I printed an enclosure for using resin printing to make this very smooth exterior for it. And then on the back side of that piece, these retainers around the corner, those white and the gray pieces there, I was actually scrambling to get this piece done, and I was able to knock those out in under 4 hours. Whereas, like, if I had to have made these any other way, would have taken an incredible amount of time, and I would have had to delay the project. So there's just so many different avenues that you can use additive for art making, and I found that it's been just a total game changer in my practice. And yeah, that's what I got.
Thank you so much, Mac.
Absolutely.
Moving right along to John. Really excited to hear from your side how you're supporting artists and how your own creativity helps them achieve their visions.
Hi, my name is John McClett. I'm here in Pittsfield at Protect Supply. We do paint, coatings, and equipment to the industry. I was given a 3D printer by his son as a Christmas gift. I don't know if it was a curse or a gift. It's challenging when you first get into it. I can give you this perspective. I opened the box, took it out. I said, okay, now what do I do? But I'm kind of a technical guy and engaged it. It's made me yell a few times, but I can say it's rewarding. It's allowed me to work and design a few pieces that I want, necessary items, widgets, from widgets to tools. We do some restoration work. So I'm able to do something like our friend Matt here in certain places. We have an artist core group locally that will come in, and we get people in that need paint and coatings. And, well, you know, it always evolves and revolves around to something different because it's all interconnected. So I've actually taken some of their designs, put them into CAD, myself and my son both, and being in Seattle, we do some Zoom calls, and then I'll print them. So I'll work with the artist in certain cases. My son may take that rendering, put it into CAD. I may print it as a prototype for them, a maquette, and go from there, and then supply paints and coatings for the larger scaled models. Not to mention a ton of other things you can do with 3D printing. And as a guy just coming into it, I would say, if you're interested in printing, do some research, buy the best printer you can afford, find a group of people around that do it, and save a lot of time and aggravation. And it will do that. And it's quite rewarding when you're done to actually conceive an idea, put it on paper, and then make the component. Just before I came here tonight, I was busy in the shop with a model I'm going to present to the artist when he comes up next week of a 16-foot piece. I printed him a 16-inch piece, and he'll love it, but it allows us to interface with the people that will fabricate the steel. It won't be me in this case. And it works out really well. So certainly don't be afraid of it. There's 1,000 directions to go, as these folks can tell you. Thank you.
Fantastic. Thank you, John. Now we're going to move to Eric and Stephanie, and if you guys want to set up the video, and then I'll pull that up.
You have the video,
I
right?
do.
Okay. Okay. I was like, okay. Hi, I'm Stephanie Weber. I direct a project called They Dance for Rain, which is a collaborative, cross-cultural dance-making project that the geographical point of focus for the project is Nairobi, Kenya. And I first went there in January of 2012, brought a bag of tap shoes, and it just grew from there quite a bit. I didn't go with the intention of exporting an American art form, but they really wanted it, so that's what I've been doing for the last 11 years, along with my collaborator, Monica, who's here. She does all the photography, which allows for us to document the project, and a number of other collaborators, and you'll hear from Eric, too, our newest collaborator. So as you can imagine, as a project grows in a culture and it has particular tools that it needs, it becomes unrealistic to always be carrying suitcases of those tools to people. The tools that are needed for tap dance are shoes and floors, and of course, training, so teachers. Me being a teacher, that was not such a big problem. I also traveled with another student of mine who is now a teaching artist, and then we started creating teachers there by mentoring. We started to deal with the floor situation fairly soon because if you're dancing on anything but a wood floor, tap dance doesn't really work very well, and it's not really good for you, for your body, and it just doesn't sound well. So if you think of tap dance as an art form that requires, it's an instrument basically. It requires your body, a tap shoe, and a floor, and a wood floor. And if all those pieces don't quite come together, doesn't work quite right. So we started working on the floor situation, which we're still working on, and Eric and I have already started talking about designs for that. But the tap shoe situation was something that needed to be dealt with. So I knew pretty early on that it was not going to be sustainable to bring shoes. So we started talking early on with our partners in Nairobi about how we could solve this problem. And over the last 3 or 4 years, we started to talk more seriously about it, mostly because of the pandemic. And it was like, well, we can't get there to bring shoes to anybody, so what are we going to do? We talked about just making our own. And so through conversations with predominantly two of my partners, Stacy Ao-Chiang and her husband Kenny, and some of these people, I have pictures that Monica took of them. They're right here. And I'll pass those out after. So you can put faces to the names. But we worked together over 7,000 miles to find the people that would manufacture the tap. But the problem was that we needed a new design. We weren't interested in just copying any old design. The taps that are out there are wonderful, but they're not fully accessible because of their size. They're sized to be made for fashionable shoes. And, you know, we don't really talk about that very often, but when you start working with lots of different bodies and different parts of the world, you realize that people's feet are generally wider than we want to believe or admit. And so a wider tap was something that we felt was necessary. So Eric and I got talking. And I'm gonna pass it over to him now, so he talks much better about the rest of this than I do. So he kind of took over the design of the tap, and he'll introduce himself, and then I guess we'll watch a little movie so you can sort of see what happened.
I'm Eric, friend of Stephanie's for a long time. So we had that conversation in the middle of Kennedy Park back, about a year and a half ago?
I don't know.
Or something like that. And I love videos of people casting aluminum, either in their backyards or in some underdeveloped part of the world. It's so cool. And listening to Stephanie, I realized that if we could find a foundry in Kenya, we could actually manufacture taps in Kenya. And so there was a back and forth with our partners in Kenya, and we realized that we found a foundry that used a very primitive method of sand casting. And so with that information and the prompt from Stephanie about the different sizes, we set about measuring
Various.
available taps and analyzing where they wore and broke and whatever. And we designed a new one. So the design was done in a program called Tinkercad, which is a web-based 3D modeling program that kids can use. And the reason why we did that is so we could, at some point, migrate this whole process and put it in the hands of Kenyans to make it as simple as possible. Because I, certainly don't want ownership over this. And what's really interesting about this whole project is handing over an art form with sort of folk roots in America, and then handing it off to somebody else and letting it grow and blossom by itself, essentially. So I designed a new tap in Tinkercad, and then we printed out a positive at Berkshire Community College, and within 72 hours, these taps came out of a foundry in Nairobi, which is just stunning.
Actually, these ones were first.
Oh, okay, yeah.
Anyway,
Those are the films.
these are the first ones.
So we're still in the middle of this process. There, a couple more iterations. We probably will have to give more instruction to our partners in Kenya because, frankly, a couple of these got squashed.
Yeah, there's a number of different, there's so many details. I've never quite been involved in a manufacturing
Yeah.
process quite like this before. So, and as you'll see from the video,
Yeah.
I was right there.
And I've trained as a designer and was really, really interested in this project because we usually make objects for their own sake. But this was an opportunity to make objects in service of the humanities, in service of an art form, which is a fairly rare opportunity. And the end goal was not this. It's cultural exchange and community building, which I find really, really fascinating, and that's the most rewarding part of this whole project for me. Without further ado, maybe we should just show the video.
Lady, how are you?
So the first pair that we had done was just straight aluminum. Do I have that one here? Yeah, this one, and these. And they broke. Yeah, so we weren't, we knew that, something wasn't right. And then our partners were like, oh, right, we forgot to tell them to put the soft metal in. So they call it soft metal. We don't know exactly what it is. When I go back and, like I said, when I get the funding to go back and do more of these, then I'll be able to get more specific on how much of what we need to make sure that it's exactly the right, tensile, the strength that we need it to be. Yeah.
Another thing I want to point out is it might be hard to see for the audience, but we left the evidence of the strata of the 3D printer casted in the actual aluminum because I wanted to leave, the thing tells the story of its making. So we could have sanded this out and made it completely smooth, but there's a little bit of a dishonesty there, okay, this is how we did it, and it adds a really cool kind of graphic element to it.
Yeah, we had talked about, if we were going to most taps have a design in them. They have a logo or something that's, carved into them. And we had talked about what would we want ours to be. And we talked about concentric circles, sort of, because that's a lot of how the project feels. It feels like these concentric circles, this rippling effect that's happened from, the moment I, came there with the first bag. So it was really cool how, when they were printed, they looked that way anyway. And we were like, wow, let's just leave it like this. This is the best way it could look. And everybody in Nairobi loved them. They loved the way that they looked, and because they're unique. Nobody else is going to have them anywhere else. We're still trying to decide on a name for the design. So we're working on that with folks out there. Probably won't be an English word, but who knows, maybe. And also the taps that you saw one of these this being printed with the metal was too cold on this pour, and that's why it didn't come out right. But I had them sign them because I thought they were really, actually, this is going to become our logo. A tap with Kenya cut out of it and a tap with Massachusetts cut out of it. So, and I save them because I want people to know that that's exactly how the project works. It's these mistakes keep happening and then they just keep becoming new things and more creative things. And it's just been a really wonderful process. And being able to 3D print just one set of taps that could have this profound effect on the project is kind of stunning, because otherwise, I don't know how we would have moved forward in this way.
It was absolutely a necessary link
Yeah.
that probably couldn't have happened any other way, so.
Your goal is 100 pairs?
I mean, my goal is tap shoes for everybody who wants them in Kenya. So I'm just trying to come up with a number to, fundraise towards. Yeah. And we're going to have to redesign or just we'll have to change, because this would be an adult size, and we work with a lot of children, so we would alter the design a little bit, make it a little bit smaller so that we could make smaller shoes. And we're also working with different fundis, different makers in Nairobi to make the actual shoe part of it too, and that's a whole other part of it as well that's undergoing right now too, in addition to the floors. Yeah.
And taps.
And taps, yeah.
All right, fantastic.
All right, thank you.
Thanks.
So much to go off of. The thing tells the story of its making. I definitely going to use that myself. What a fantastic way to phrase it.
I've copyrighted that.
Yeah. Okay, don't worry, you'll get your
You have to
royalties,
pay
Eric.
him a little bit first.
Yeah.
Sorry.
I want to be the middleman. Agent.
So Eric mentioning that the goal here is not the taps themselves, but the dance that's enabled by them. Makes me think about the portability of design. So you're sharing designs across the world. The design themselves is enabling further art. So my question, and I'm actually going to push this one back to Mac, is with that in mind, how do you think differently about your audience and how they're engaging with the art as a result of it using a different creative process?
Yeah, so I think that basis in the materiality of how it was made is incredibly important to it. For instance, like the Canon piece that I showed is entirely based around that idea of 3D printing, and I made that piece in particular. I made it so that the layer lines were incredibly prominent. Printed very thick layers. I think it was like 0.6 millimeter for those keeping count. And so that you could like run your finger along it and like very obviously know that this was not like injection molded or like cast in a normal sort of way, but no, it was very distinctly 3D printed. And within that same context, like I've gained so much from like open source tools and open source technologies that typically I will make the design files for my projects open source as well and publish those. So that way, like for conservation purposes, people can go and like look at how exactly I did something, and or like if people are inspired by what I do and go and want to build off of a process that I was able to develop, then they're able to just like scroll around the code, or in this case, like look at the actual 3D files that I'm generating. And so that way they have like a much longer lifespan than just my specific use for them. And I found that that's an incredibly generative process as far as like building a community around the arts that I'm making.
Thank you for that.
Just to
yeah.
go off that, I had an arts lawyer once tell me, don't worry about people stealing your work. Worry about people not stealing your work. And that's one of the most exciting things about like the 3D printing and additive culture. It's created this really, really interesting kind of remix culture that we're hoping to kind of build off of, like just handing off this project and the digital files and the means of production to other people.
Yeah, I think that's a fantastic alignment between 3D printing and arts in general. With the open source movement, people share the files to design or produce whatever it is that they've made. So Mac mentioned earlier using a printer at his college to print parts for a RepRap, which is an open source design that allows people to produce their own low-cost 3D printer using largely 3D printed parts plus vitamins, which are the stepper motors and linear rails and belts and things that can't be feasibly printed. But in art, you're being inspired by and learning from other artists whose work you admire. With tap dancing, you're learning from an instructor. You're working together to nail the choreography. And those two are just so strongly aligned. I think it's no surprise that we're seeing a big increase of use of these digital fabrication tools alongside the artistic creative process. So segueing from that, we've seen a bunch of examples of how the production process of these art objects has been changed. Eric, could you maybe share how it's actually changed your approach to design in the first place, knowing that this would be the method used?
That's a really good question. I have a master's degree in industrial design, but my heart is in social movements like this, and I was at the Berkshire Community College, and before that I was working for Habitat for Humanity. Back to your question, it's helped me kind of maybe focus or at least discover a certain track that might be possible, and a relatively untrodden path, and it's as I said before, like, the thing in itself isn't the thing. It's what it enables people to do. So that might be a really vague way of answering your question, but.
No, that answers it. So John, I think a lot of us who are relatively early adopters with this tech find ourselves, whether we want to be or not, in an ambassador position. So with the artists that you've worked with, have you found yourself kind of needing to explain what this technology enables and how they might think differently about what they're doing?
Yes, I have had to do that in many cases. Because many of the folks out there haven't been exposed. They don't know what it is. They've heard about it. We have quite a core group of artists in Berkshire County. There's no question about that. And this is not new technology, but it's new to many people, as it was to me, even though I've done many other things. So I find myself now explaining ways they may produce something up front for much less money and simpler. And as we all know, artists tend to change at the drop of a hat. It's the art form.
What do you mean?
What do we mean? And 3D printing something allows that quickly. You can put it on paper, get it in CAD, print it. Oh, we need to move this. Okay, simple, right? And you can have another until you're very happy with a product, and then take it and scale it from there. And that works pretty well for people and the folks I've worked with to date.
Great.
If I could build on that, I found that CAD, as much as anything, has become my new sketchbook. Like, I'm very able to quickly iterate through ideas. And like with 3D printing, like I'll think of the rough form of something, press print, be able to hold it up in front of me and think, that doesn't really work. I can go and change it right quick. And just being able to go through those iterations so quickly it's like an incredibly helpful process in that way.
Thanks, Mac. We're going to shift now to audience Q&A. If you raise your hand, Jordan will come over with a microphone. I've got one up in the front.
I have a question about materials. What materials can one print in? I work in metal.
I'll just give the quick overview. So there are quite a few resins with a wide variety of properties. Generally speaking, they're photopolymers, so you use an ultraviolet laser or LED to expose them and solidify them. Included in resins are some new ceramic and even silicone materials. There are a variety of different metal printers that can do 316L stainless steel, 17.4 pH, titanium 6.4, aluminum alloys, copper, quite a few other metals. Inconel is a really common one for 3D printed metal. Within the world of thermoplastics, which is what most people think of when they think of 3D printing, FDM printing, you have a plastic filament, which is melted, extruded through a nozzle, re-solidified into your part. PLA is probably the most common. It's derived from cornstarch or cane sugar, other organic materials. So it's used a lot in educational settings because it's viewed as being the least harmful of those thermoplastics. It's also very forgiving of temperature fluctuations, which is a large cause of part failures. But there are many other materials. So ABS is pretty common for applications like a part that would go inside your car where on a hot day, the inside of your car might get up to 150 degrees, which is enough for PLA to start to sag. PETG, polyethylene glycol, is really popular. It's similar to the plastic used in soda bottles, and actually there are quite a few different ways to recycle soda bottles back into filament now. But PETG is a little bit more impact resistant and a little strainy, but generally easy to print. There's flexibles, TPU, thermopolyurethane, or TPE, thermoplastic elastomer, some flexible materials. Nylon is often used as a composite. So nylon itself is pretty malleable. So it's really impact resistant because it yields a little bit. But if you add some stiff fibers back into it, you can get a part that's both resilient and stiff. So one of our printers here uses a mix of PA11 nylon and carbon fiber reinforcement. So we can get parts that are 95% as stiff as aluminum, but weigh half as much. There are also some cool materials. One of my favorites, Ultem, actually was invented right here in Pittsfield. Ultem is an engineering plastic, which basically means it's really expensive and nobody would use it unless they have to. But what it does very well is withstand heat. So you can run it through an autoclave. So it's used in a lot of medical applications because you can sterilize it. So instead of being a single-use product, you can get more uses out of it. It's also viewed as one of the most biocompatible materials. So if you are implanting something into the body, Ultem's a common option. And there are tons of others, polycarbonate, polypropylene. Anything that can be injection molded, in theory, can be 3D printed. It may not have great properties for that. But yeah, that's a quick overview. Sure, of course.
If
Yeah.
I was to add on to that, for metalworkers in particular, one of the best uses of a 3D printer is for making the sort of jigs and tools that are always around metalworking. So say you have to put the same hole in the same place on 100 different beams. You can very quickly print out a jig using ABS or something like PETG that'll put that hole exactly where you want it, like on a pipe. And you can just very quickly knock out that whole location again and again and again without having to remeasure and remark and do all that sort of stuff. And yeah, it's just super helpful for those sorts of applications.
Yeah, so jigs and fixtures are a fantastic application. Last year, one of the BIC members asked if we had a CNC machine to help them modify a bottle cap for a vial. We don't have one. They'd gotten a quote from their usual CNC company for about $2,500 for the setup, plus a per part of actually drilling these holes through. But I spoke to them and said, we have a very nice drill press and a pretty precise printer that could make a jig that could hold your part relative to the center of the spindle. If you go back to your customer and they're okay with a slightly relaxed tolerance, we could do this for you. Customer was fine with that. So with a couple hours of my time and printing a few small pieces, we were able to do all those parts for about $250, where the original quote was 10 times as much. So in one single job, they could have paid for not only my time to do the work, but the printer that I used to make those parts in the first place. So a lot of it, a lot of our job here at the BIC is helping people find these use cases, because you never really know where 3D printing can apply until you run into the issue. And I think that that's actually very similar for artists, where you're looking for use cases. Like, where can this thing that I know how to do, this thing that lets me transform one thing into another, how can I apply that to some creative expression, something that I want to get out? Next question.
Well, I only had one question when I started, but now with all the information you gave, I have three. So I think that primer was so helpful. Like, where can we find that? Or you should put it together and, because how do I know what materials I want, depending on what I'm making? And I'm definitely one of those fickle people, right? That I'm going to keep on, not fickle, what did you say? Touchy artist that likes to keep on changing it up. So that's one thing, so that's something. The second thing is, we talk a lot in kind of product development about unit economics. So I'm really curious about some of the cost per product, not even all in the unit, just the basic costs. And then the third part would be what you just said. What if we want to get something made? Do we just come to you? What's the process of, like, we have an idea, we have a concept, and we, want to start executing on it?
So I'll quickly answer 1 and 3 with this slide. And the second point here, the Berkshire Athenaeum actually has a 3D printer that is free to use with only a library card. And if you want to take a picture of this slide to get this URL, their website also includes some pretty great links to resources to learn about the process. And Sydney, if you go to their reference desk and ask for Sydney, she's a really fantastic librarian who will help you understand not only how to use the printers, but where you might find applications to print things for yourself. The second question on unit scales, we talk about that in manufacturing all the time. When a member calls and says, hey, can we print this? Can we laser cut this? The first question is, well, are you making 1 or 1,000? And sometimes they don't know. So sometimes we'll recommend it as a prototyping process to say, well, for now, your client needs to see 1 of these. Maybe they want to order 100 and we'll keep printing them. Maybe they want to order 1,000 and you go to some soft tooling. Maybe they want 100,000 and then you go straight to traditional injection molding. It's a very, very per case kind of process. It depends on the size of the object, the complexity, whether it's already been designed with other manufacturing processes in mind. Not every shape can be injection molded. You have to be able to separate the mold after the fact. So there's a lot of geometry that just isn't good for that mass manufacturing. What is really interesting though, so there are quite a few graphs you can find out there, I'm sorry I don't have one in the slide here, that show the cost of manufacturing processes with volume. With injection molding, over time or over volume, the cost drops off because the upfront tooling cost is amortized over each of the individual pieces, and the electricity and plastic to produce each part is really marginal compared to the upfront cost. With 3D printing, it's a static cost. Your first part costs the same as your 100th part costs the same as your 1,000th part, generally speaking. What's interesting though is if you add another variable, complexity, the more complex your part gets, the more expensive it is to produce, like I mentioned earlier. So we have an exponential curve going into the only NASA can afford this if you need to keep someone alive on Mars, and we generally don't make things that way if we don't absolutely have to. With 3D printing, the machine only spends time depositing material. And generally speaking, complexity is correlated with lighter parts. So NASA's really complex parts that are way expensive to produce for an application here on Earth are so expensive because they're removing as much material as they possibly can to make that weigh as little as possible. So this is a bit of a rule of thumb, but generally speaking, actually, as complexity increases, 3D printing gets faster and cheaper because there's less material actually being printed. So it's an interesting quirk which isn't directly related to volume, but as you think about it as an alternative to other processes, it's a really important consideration. Sure.
Is a cost of like 1 pair of taps? Like what are we talking about?
For just the taps or the whole shoe?
Well, I don't know, like that piece.
These taps?
Yeah.
I think we figured out that we're going to be able to produce like a set, like 2 sets, like for a pair of shoes for a little bit of under $10, around $10, American dollars. But if we do more, he gives us a little bit of a deal. And this is like, these aren't machines that will be making this. It's just like what you saw. It'll be like a team of people making every single one by hand.
But with the upfront design costs, that were very low.
Well, it was just us. Yeah, yeah. It definitely would have been different otherwise. Yeah.
How much are
Guys, if you could hold on for the microphone just so the folks viewing remote can hear the question.
Oh, yeah. How much would, can you, how much are American taps?
So, like more than $10. Let's put it that way.
I think the pair of Capezios that we looked at,
They're like $30.
they're like 35
Yeah.
retail.
Yeah, yeah.
But
And that doesn't include the shoe.
So I'd like to build on what you said today about the Athenaeum. We were using a 3D printer there today,
Oh, fantastic.
and Sydney's very accomplished in it. And I heard through the grapevine that BIC is going to be donating a 3D printer, an upgraded version to the library. So we were thrilled on that.
So yes, but before we take too much credit, it was actually donated to us by Williams College, and I realized that it would be better serve the community if we rehouse it there.
Great, great. So anybody can come, and with a little education, you can print out your items, objects. There's been some very interesting things that came out of there. Now a question for Mac in terms of the cannon. Very intrigued about the cannon. Looks like a cannon, feels like a cannon, the size of a cannon, 30-pound ball. Can it shoot like a cannon?
The only thing it's shooting is ideas into the minds of the viewer.
So then a second part of the question is any technology, good and bad. We've heard about the nefarious use of ghost guns. Can you talk a little bit about that and your thoughts on what we can do about the nefarious uses of 3D printing?
Sure. I mean, a 3D printer is a tool like any other in that any tool can be used for good or evil. The classic example is the double-edged sword, where you can make your dinner with it or you can go cut your neighbor with it, right? 3D printing as used for the production of firearms is it's becoming more common as people understand that these tools are more common, but as much as anything, that's just because more people are using them. A greater share of people are utilizing 3D printers, and so a greater share of people are also using them to produce parts for firearms. As far as the actual control of that information, I think it's a tricky issue. Just because what is being shared isn't physical objects anymore. It's the schematics. And that's part of the wonder of 3D printing, is that you don't have to give somebody a USB drive to make an object anymore. You can go and just email them a file very quickly, and then you can have this object in two places simultaneously, right? But I think that's up to local areas to figure out how they want to handle it, and regulation is really going to be the only way to limit that sort of proliferation.
I know that New York State is actually considering some regulation around owning 3D printers with that concern in mind. So certainly nothing has been figured out yet, but it's a discussion that's starting to happen in bigger and bigger venues. Sure. Yeah, drones are a great example. Yeah, and just as Max said, really any technology, if you have access to an inexpensive metal lathe, you could build a much better gun than you could 3D print one. But that takes a little bit of time and skill to learn how to operate a lathe, where many printers don't need as much. There's a lower barrier to entry. So it's a legitimate concern. It's probably blown a little bit out of proportion, just considering there are so many other ways for bad actors to act badly. I think Jordan has a question from our remote participants. Thank you. Okay. I love what our panel is doing with 3D printing. I'm also thinking about two other 3D printing applications that I wonder if anyone in Berkshire County is investigating. One is printed food, and particularly I read about a project in Japan that was using whole salmon, including bones and skin, to print highly nutritious salmon steaks for hospitals and rehabilitational institutions. More nutritious and almost no food waste. The second is 3D printed houses, and particularly ones that use the soil dug for the foundation as part of the printing material. Building a whole house takes only a day or two, and we have a significant shortage of affordable housing in Berkshire County. I'm going to take the second one because we do get asked about this pretty often here. There are a number of companies doing 3D printed homes. Generally speaking, they're using a concrete extruder on a robotic arm that moves around and around. This is more of an economic issue than an engineering issue. This technology exists, it can be done. But the question is why? Typically when you're building a house, the framing is the cheapest part of it. Your foundation, your roof, your electrical, your plumbing, your trim carpentry, your fixtures, all of that are more expensive, and they still need to be done with a printed house and are often even more expensive. What 3D printing a house allows for, though, is complexity, which is a word you've heard me say a lot tonight. Raise your hand if your house has any corner inside that's not 90 degrees. So there might be one or two, but generally speaking, we have right angles everywhere. And that's fine. That's not a bad thing at all. But if you want unique architecture, that's where I think there really is a future for 3D printed houses, where you want interesting curves, where you want arched doorways, where you want things that would ordinarily take, a really skilled mason or tradesman a long time and quite a few billable hours to produce. That, I think, is where we'll see the technology shine. As for printing food, I don't have a good answer for that, so hopefully one of our panelists maybe has some thoughts on it. Mac, has that surfaced in your world at all?
I have not personally interacted with it prior, but there is a very interesting project that is being, I think it was just released within this past week. It's called the Cocoa Press, where people have like a syringe filled with this flowable chocolate, and it's able to build like 3D chocolates all on its own, which is a very fun way to like put together those sorts of things. Another good point about the 3D printing of structures as well is that they are very fire resistant. Something y'all don't really have to worry about too much in Massachusetts, but over on the West Coast with some of the forest fires, like those sort of structures are invaluable.
That's a great point. And Mac, as you described the chocolate machine, I'm reminded of Scott Janusek. Mac and I used to be members of a makerspace out in Somerville. And one of the other members had a pancake bot where you could mix up the batter and put it into a syringe, and it was mounted over a griddle, and you could print a pancake in whatever shape you want. And if you think about cooking a pancake, whatever the batter goes down first comes out darkest because it's on the griddle for longest. So you can actually change the tool path of the syringe to put whatever you want to be darkest down first, and then lighter all around. And pretty trivial use case, but they do exist.
At the college, we had considered acquiring one of the chocolate printers. They were pretty cool. But it brings up a really interesting issue, is that 3D printing, for all of its benefits, isn't the best process to use for everything. And I think these two cases, food and shelter, are what am I trying to think? It's sort of a novelty, you know. It's you know, if you've ever seen Amish barn raising, it's really incredible. The whole town can raise a building in 2 days. You know, you can't do that with a 3D printer. And with food, we thought a lot about this at the college, and what I wanted to do was actually, instead of having the 3D printer be the thing that makes the thing, is the 3D printer is the thing that makes the thing that makes the thing. So instead of printing the chocolate, you print the mold, or you print the positive that you make the mold from. And I think that's the mix of both digital and analog processes are where I see sort of the on-the-ground use of this stuff is. So.
Yeah, thanks, Eric. We're running a little bit over, but we did start a little bit late, so I think we could probably take 2 more questions. Does anyone, just to give everyone a chance, is there anyone other than Eileen? If not, she has a great question. So,
I work with a lot of early stage entrepreneurs, and I'm wondering what the trend you see in terms of maker spaces versus 3D printing, the balance, that kind of issue about, what shouldn't be made in a 3D printer. So when someone has an idea for a new product, obviously we know it's a lot more expensive if they go a traditional maker space, but I just love your ideas on what you think the trends are and what we're going to see.
I think these tools are getting accessible enough so that instead of maker spaces, people can actually acquire the tools themselves. So, the 3D printer can run you, $150 and up. That's at the heyday of the maker space movement, which was about 10 to 15 years ago. That wasn't the case. So a lot of these tools now are accessible to the individual, or accessible at the library to figure out, yeah, I do actually want to buy one of these. As to other aspects of makerspaces, I worked at one in Detroit, and the community aspect of it is not something that is easily replicable. Maybe a place like here, but, to just be able to work in a space every day where other people are doing really interesting and cool stuff is really inspiring and kind of pushes you, so.
Show it.
Oh,
It's
Jesus.
incredible.
What is that?
Somebody hold that up, Stephanie.
That's a,
That is printed.
that's a thing I printed.
It's a thing.
It's a thing,
It's a sculpture.
yeah. I brought it to talk to Tim about doing it bigger. That's why it's here. It's incidental to the whole
And I wouldn't
project.
hide it under the table, so.
Well, we can do 102 centimeters tall in one piece.
What's that in English?
It's 3 feet 2 inches-ish.
Could you do it in two pieces and do it like 6 foot?
Absolutely.
All right, we'll talk later.
Got it. All right.
I just,
Any final questions in the room? Yeah.
What's the learning curve for the software involved with the 3D printers? It seems like that's a barrier to entry for me, is just that I'm not used to working with those programs.
Sure.
Yeah.
So I'm going to take that as the perfect segue into this slide. So some free resources at the top here are 4 different websites that have 3D models already there. So there are quite a few objects that you can download somebody else's file and print it yourself. But in order to learn for yourself, there are many CAD platforms out there. We tend to use Fusion 360 or SolidWorks here at the BIC. As Eric mentioned, Tinkercad is really easy entry point that's sort of designed for school grade kids. So it's a great way to start even as an adult because it makes the concepts really clear, and then you can graduate to a more sophisticated tool if you need one. But there are 2 main software tools. There's CAD, computer-aided design, where you produce a solid body model. And then there's a slicer where you take that model and convert it into code that your printer can actually run. That second piece, the slicer, if you are making something that's not incredibly complex, has kind of gotten to a point where you can just use default settings and just click slice and throw it onto a printer and click print and probably get something good. So that piece, I'd say the learning curve is very, very low. CAD, the learning curve has gotten much lower, but I think that always just makes people more ambitious and they wind up spending kind of the same time. They just become better designers by the end of it.
Are you using ChatGPT at all for programming?
I haven't, but I've seen some cool examples. And what's really weird about ChatGPT as a natural language model is you don't have to ask it, generate a 3D model for me, and then take that 3D model and turn it into code. You can just say, generate the G code that would produce this 3D model for me, and it somehow parses that into something that, I don't know, maybe works like 10% of the time. It's certainly not a solved problem yet, but it's evolving so quickly, who knows? Matt probably has a better perspective on this.
I actually just recently used a tool that works similarly to the image generation AIs, but it's made specifically for generating 3D models. And what it's doing is sort of using this hybrid process of making a whole bunch of different photos of one thing and then doing what's called photogrammetry on those resultant photos, where it's able to like sort of visualize an object from multiple different angles and interpret what the 3D object would be, and then like make that 3D object in a format that can then be printed.
So finally, we have one more question from the internet. I work for a nonprofit and we use 3D printing for adaptive equipment / tools for people with disabilities. Is there a way to make bulk product in your space? The short answer is yes. The slightly less short answer is my email is here in the bottom left, tim@thebic.org. send me an email with what you're thinking, and we'd be happy to try to accommodate you. We do have a print farm here. We have dozens of individual printers. What we do not have is a ton of excess staff time, but if we're able to train some people in your organization to come in and use those printers, we'd be happy to help with that. So with all that said, I'd love to ask for a big round of applause for our excellent panelists. And thank you all for coming out to the BIC. I believe there's still food and drinks just outside the door, and we'll have a little networking.